There is an increasing interest in using the CNCPS model even in the beef industry other than dairy industry as an alternative to the conventional tools designed to evaluate beef diet. So the goal we have now is to describe some basics of the CNCPS model for the beef side, and to show you some additional features that we developed within NDS. The first step is to even here is to describe how we can properly handle the animal inputs. The beef section of NDS is able to formulate a diet for different type of beef, and they are growing and finishing beef cattle, lactating beef cow and dry beef cow, and also we recently added the backgrounding, the beef backgrounding, in order to evaluate the diet for young beef fed mostly with mostly forage diet. Let's work with beef cattle. We can define which kind of type of beef we are working with, growing or finishing. We can work with different type of crossbreeding or straight breed. We can work with just a major breed, with a two-way cross or a three-way cross. In this example, I am working with a two-way cross Charolais per Hereford. And this is quite important because in background, this definition is quite important because in background there are some settings related to the breed that the model need to consider before to run the calculation. We have to input the age of the group. It is not a critical information, and many times we do not have this information. So we have an algorithm that, based on several items, tell you more or less the age of the group. And then we have to set the current full body weight and the mature full body weight. Let me describe how we consider these inputs. The mean full body weight is something important because it defines many aspects of the requirement calculations, but in many conditions we have no idea about how the mature body weight is. It is an input, it is a critical input, but we cannot measure the mature body weight like we did or we can do for dairy. So we decided to use a different approach for this input, and we defined some mature body weight by default, and you can see here in the expected mature body weight what would be the mature body weight used in this specific situation with a crossbreeding Charolais per Hereford, in order to have an idea about the whole growth curve. So under this situation, basically the mature body weight, this input do not have a significant impact in the outcomes. Another aspect that I would like to mention is the type of input we can select in order to define the average daily gain. We have the simple inputted average daily gain. That means that we can set a current body weight. The system will work with the expected mature body weight, and we need to input the desired, let's say, the desired average daily gain. This is not what we suggest. We suggest to use the period in, period out input body weight. In this way, we have to input the starting body weight. I mean, the body weight at the beginning of the period that we define period in full body weight. In this case is 500 pounds, and the corresponding period out full body weight that should correspond to the slaughter weight. In this case is 780. Not necessary, this is in reality the body weight at the slaughtering, but it could be, it depends on the type of group we are working with. In this case, we input this period in and period out body weight, and based on the days on feed or the days in growth period, the system calculates for us both the expected average daily gain and the mean full body weight. Both numbers are in red just because they are not a direct input, but they are calculated from the period in, period out body weights and the days on feed. Then we need to define, to set the type of animal we are working with. I mean, male, female, or steers. In this case, we are working with male, entire male. If we would use additives, there is a list of possible options, and based on these options, the model will provide some adjustments in the growth rate and in the expected dry matter intake, and the final body fat. The final body fat is another input that it is not easy to define, because many times we see that the users do not change this input, leaving always 28%, 25%, it depends on the default they are using. But this is not really correct, because it depends on the stage of growth. So we included some evaluations in order to identify the expected body fat in terms of percentage of the empty body weight, in order to have an input, a more realistic input for this group, for the group we are working with. Otherwise, we have to input some default number that many times do not help to be accurate in our predictions. Based on these guidelines, period in, period out, input of the 2 weights at the beginning, at the end of the days on feeds, based on the final body weight, the system is suggesting, because we suggest the expected final body weight. Final means at the end of the period. We can have a set of input that should help the system to predict, to have a average daily gain predicted much more accurate than if we set this input in a different way, like input average daily gain. And we can describe, in this way, we can describe different groups of animals during the whole cycle of growth. The grounding, beginning of the growing period, ending on the growth period, finishing period, based on the period in, period out. Of course, if these groups are receiving different diet. If we go on on the recipe screen, again, we can focus on the major aspect of the outcomes that the model is able to provide. The first is always the dry matter intake. It is critical to know the real dry matter intake of our groups, because sometimes the predicted intake doesn't describe properly the current one. And given that the system, the CNCPS system, works mainly with supply, energy supply and protein supply, we need to have the real dry matter intake in order to better evaluate this supply. Always the section where we can have a summary of the animal inputs, and some of these values are changeable, and then the outcomes in the CNCPS summary sections. We can customize this section, and I work mainly with these parameters: ME and MP allowable gain, rumen ammonia. I want to know if I add urea or not in the diet. I would like to monitor the physical effective NDF, mainly for finishing cattle where the forage level is very low, and I want to monitor to have the minimum of physical effective NDF, and then some parameters that sometimes I check: net energy for maintenance, net energy for growth, and the amount of metabolizable protein as a percentage of dry matter intake, and as a ratio on metabolizable energy. Okay, so here I am highlighting the average daily gain allowed by ME supply and average daily gain allowed by metabolizable protein. Of course, we should have here the predictions quite close to what we measured as real average daily gain during the period. In this case, in this group, we checked almost 1.7 pounds per day, and this is the average of the period. And we should have a very close value here when possible, in order to be sure that the model is calibrated. Not always this is possible, because greatly depend on several inputs, starting from the dry matter intake, but the objective is to have always to check always the calibration of the model. Metabolizable protein, talking about metabolizable protein, I may want to underline that we still have here a similar issue we described for heifers. In other words, many times the CNCPS model over-predicts MP allowable gain for the reason we described before: passage rate, microbial efficiency. So even here, the major driver of the predictions, of the average daily gain predictions, is the energy supply. We also added some additional evaluations that are only included in our platform, in order to give to the user an additional option to evaluate their diet. And we called this as beef growth model. Let's discuss first about the performance tab. The performance tab is a summary of the evaluations that NDS is able to provide, making a comparison between the CNCPS prediction and the beef growth model prediction. The beef growth model prediction is able to provide two different average daily gain predicted. One is called current average daily gain. That means that based on the diet we are formulating and based on the current metabolizable energy supply, the system predicts how much our beef are growing now. A second prediction is called period average daily gain. that means that this prediction describes the average of the prediction over the days on fees in order to compare this value with the CNCPS ME allowable gain. In this case, we have 1.611 pounds predicted by the CNCPS, 1.75 predicted by the beef growth model current average daily gain, and 1.709 during the whole period of growth. Why we decided to give this second option? Because in some cases, based on some inputs not included in the animal input appropriately, sometimes we notice that the predictions of average daily gain should be, let's say, disconnected to the requirements and should be much more related with the real metabolizable energy we are supplying with the diet. Let me show you some basics of the model. We calculate the ME supply based on the CNCPS model, and we use this ME supply to make some evaluation about the anabolism of the tissues versus the catabolism of the tissues in order to evaluate the net energy available starting from the ME supply based on the CNCPS. And we use this net energy estimated by this process in order to provide a different way to estimate average daily gain. Another advantage that we think we can provide with the beef growth model is that we included the capability to better predict body composition over the whole period. So we can estimate average daily gain, but also the expected body composition at the beginning of the stage and at the end of the stage. And if the end of the stage corresponds to the slaughter, we can predict the body composition of the carcass and of the non-carcass tissues. All these, while in the performance tab, we summarize some of these outcomes, opening the beef growth model, we can show several details about what I said. Different sections. Here we can have in the first top left tab, we have basically a summary of the inputs, in lot weight, starting weight, the current weight, that is the average between in-lot weight and finished weight. The rank weight, I mean the current weight discounted by 4%. The empty body weight, we remove all the digestive content from the total body weight, the current body condition, and we estimate the current body composition in terms of protein, lipids, and water plus ash. We estimate, we show here some characteristics of the diet: current dry matter intake, expected ME supply based on the CNCPS, concentration, metabolizable protein supply, concentration, if we use additives or not. Then we have the predicted growth at this stage of growth, right now, feeding exactly this diet. The expected growth is 1.75 versus 1.60, 1.7 that is what we observed, empty body gain, and the composition of the gain. The final body weight, finish weight after the days on feed, the system predicts 164 days on feeds to reach this final weight, the final rank weight, the final empty body weight, the expected body condition score at the slaughtering, and the body composition at the end of the period. Then we have some outcomes related to the period of growth during these 164 days. We have 1.709, 1.71 as average daily gain, 1.57, and we have another way to evaluate the MP allowable milk different than what Cornell provide, and in this case we predict based on the nitrogen and the energy and different aspects, we predict 1.2. And the desired average daily gain, desired or observed average daily gain is 1.7. In the bottom part of the screen, we have some evaluation related to the carcass and to the non-carcass part of the body with the weight and the composition. In the right hand of the screen, we have some description about the growth curve predicted by the growth model, the beef growth model, and this is the expected average daily gain through the period. The blue line, the blue vertical line describes where we are now, and the horizontal green line describes the average over the period, and the period is described with this alarm zone that is light orange or something like that. We can do the same evaluation for the growth. Okay, you can see that at the final of the period, we have around 780. That was what we expected. Full body weight, empty body weight, the light green curve, and the body composition in terms of lipids and in terms of protein. these are pounds, not percentage. This is not the concentration, but the pounds of each item we expect. And this is, in these two curves describe, the blue curve describe the energy intake, energy supply over the period, and this describe the dry matter intake over the period. This is basically the detail of the performance, and we called this tab as performance projection. But we also added an additional features that we called financial projections. And here we can have a summary of the financial aspect that we can predict based on the beef growth model. There are some additional input here based on the number of animals in the group, mortality, starting weight, buying price, selling weight, selling price, yardage cost, vaccine and implants, other cost, interest, and the days on fees that correspond to what predicted by the beef growth model. We have the diet with some economical aspect of the diet. For example, the cost per head per day, the pounds of dry matter, all the information related to the diet. Here in the light green section, we have a summary of the outcomes with some efficiency parameters, expected feed gain or expected gain per feed, according the different perspective. We want to evaluate the efficiency. Some cost for the whole group based on feed, veterinary and others, yardage, interest, and mortality. All these information are summarized in this section, light blue or azure section, where we report the net gain per head in terms of pounds during the days on feed, the gross income, the total cost, including fees, including all other costs, yardage, everything, and including also the cost of the calf. So we included the total cost of the growth period, but also the cost we had buying these guys. This is the expected net margin, not a lot, but this is what we get. The feed of the feed cost per pound of gain, the additional cost per pound of gain, and the total cost, including the calf cost. And at the bottom, we have an evaluation about the break-even for live selling price, and we have an idea about having this overall cost, an idea about the maximum cost that we can have in buying new beef, new young beef, to maintain this level of profitability. In other words, the break-even point is 133, in this case euros, but it could be per hundredweight. We spent 1.329, and if we are gonna buy the new the replacements at 134, you will see that we have to reduce the other cost in order to maintain the profitability. Otherwise, we are losing money. This is what we did. It is quite complicated to have good predictions for beef animals. But we continue to monitor several diets, and we continue to make some comparison and some validations of what we are doing. And right now, this is what we get in terms of evaluation of what we are doing. We put together some diet where all the data were well collected, including dry matter intake, and we compared the observed average daily gain. Here we are in kilograms, but just to give you an idea, and here there is the deviation between observed versus the predicted. And you can see that we are quite good in terms of the prediction, even though we have to recognize that sometimes we have outliers, and in this case we need to verify very well all the inputs, including the feed characterization, because many times we do not have proper feed characterization and dry matter intake. This is what we did. We are not recommending to use beef growth model instead of the Cornell model. We provide both. We leave you to monitor both in parallel in order to have a better evaluation of what we are doing in your beef enterprise. I don't know, Dave, if you want to add something through some examples.
Yes, I think we'll look at just a couple examples. We do have the step feeding that we want to get to. So I was trying to, Kurt, I was trying to answer some of the questions online so we can see. My approach when using this, Hermano, has been knowing that we can put in the animal inputs in, and then knowing that the model, with the better feed characterizations that we have, we can actually go into this and put together a better prediction of ME. And then, as we have discussed this and talked about it, the ME will drive the average daily gain prediction. So I just brought up a bunch of diets that we had been working with, and a couple of the things that you can do is, so if you go in to describe your farm and you are working in beef, you can even do this under the same farm, but you can describe the pen for the inputs of the beef backgrounding, a beef dry, replacement heifers, a lactating beef, and then the beef cattle goes ahead and brings in that beef submodel. And in what I have seen working with this is, once we start feeding excessive amounts of starch in these finishing feed yard diets, and this is one of the diets that we worked with at one of the university groups, and we're working on this diet, looking at some of the performances, but going right into the beef growth model. and looking at the predictions that we were looking at. And this was one of the grad students at university, and they had some data on there. And so we were pretty tight with our predictions going through here. Again, in the setups, one of the questions was, so if I go in here and I look at this animal, the mature body weight, you know, for a Angus animal, again, a mature male, you know, this may be as far as, you know, we could put in 1,900 pounds here. But the key for this input is the period in, period out. We are worried about this period right here in this growth stage of the animal going at 110 days. Again, this was Argentina. We were feeding out intact males. One of the questions that surfaced, Hermano, was, and I've had this before, as far as if someone's growing dairy bulls, we would probably not want to use the finishing beef system in that. You'd probably want to go backgrounding beef to try and put 2 and 3 pounds of gain on a bull, not 4. But you can decide male steers here. You can go into castrates or, you know, males. In this example, we were feeding intact males in that Argentina thing. Also here, a question that came up was the information that was supplied. Hermano used the implant data from some of the beef guys in the United States and came up with different estrogen, androgen combination implants that will show you that different effect there with ionophores. So there is some flexibility here. So this is the area where I would use that beef feed yard module. And I have not been paying attention to this MP. I've been going right into the average daily gain over the period and the present. Just looking at a couple different options. Here's a backgrounding heifer diet, and choosing to run that as a growth animal, beef backgrounding, beef growth, using the CNCPS system, again, paying attention to where this energy gain is. And then even looking at the beef cow submodel, and this has got a bunch of age on it. I think this is one of the first ones I did in 2016 with one of my guys. Basically, it doesn't take a whole lot to make, you know, basically 2 gallons of 4233. And when you start looking at the feeds, you can understand, you know, how that works in the beef lactating.